Electric field lines or lines of force. It is pictorial representation of electric field around a configuration of charge or charge. In general, it is a curve drawn in such a way that the tangent to it at each point is in the direction of the net field at that point. The closeness of field lines at point represents the relative strength of electric field at that point. Properties of field lines. First, field lines start from positive charge and end at negative charge. If there is a single charge, they may start or end at infinity, as shown in the figure. Second, there are continuous curve. These are continuous curve without any breaks. Third, two field lines can never cross each other. If they did, the field at the point of intersection will not have a unique direction, which is absurd. Fourth, electrostatic field lines do not form closed loops. Area element. A smaller part of area is called area element. It is a vector quantity, symbol delta S vector ds vector, infinitesimally small. The direction of area element is perpendicular to the plane of the area. Mode of delta S vector equal to mode of delta S into n cap equals to mode del S into mode n cap equals to del S into 1 equal to del S. Mode of n cap is 1. N cap is unit vector to the plane area. Component of area delta S vector equal to delta S cos theta I cap plus delta S sin theta j cap. Here delta S vector dash बराबर delta S cos theta I cap equals electric flux. The relative number of electric field lines crossing the given area normally is called flux of the electric field. Mathematically, the flux delta phi of electric field E vector through a small area element delta S vector is given by delta phi equals to E vector dot delta S vector E into delta S cos theta. Delta S n cap E vector, angle between delta S vector and E vector is theta. The total flux through any given surface is phi equal to sigma I equals to 1 to n delta phi I. Sigma I equals to 1 to n ei vector dot delta Si vector. If electric field is constant for a elemental area, then Ei tends to E vector and phi equal to sigma I equals to 1 to n E vector dot delta Si vector equals to E vector dot sigma I equals to 1 to n delta Si vector. This implies phi equals to E vector dot S vector Es cos theta, equation 2. Differential form d phi equals to E vector dot ds vector, hence phi equals to integration d phi equals to integration E vector dot ds vector, equation 3. From equation 2, phi maximum when theta equal to 0 degree and minimum and maximum value of flux is phi max equal to Es cos 0 equal to Es. When electric field lines are perpendicular to a plane of area, flux is maximum. B. Phi equals to minimum when theta equals to 90 degree and the minimum value of phi equals to 0. The flux is minimum when the plane of area is parallel to the electric field. Next point, field lines of uniform and non-uniform electric field. Uniform electric field lines, non-uniform field lines. Unit and dimension of electric flux. Unit phi equal to E into S, Newton per coulomb into meter square, Newton per coulomb meter square. Phi equal ES equal to 1 by R, V by R into S, or volt per meter into meter square, or volt meter per meter square. Voltmeter or voltmeter. Newton per coulomb per meter square, kg meter per second square, ampere second to the power minus 1 meter square, kilogram per meter, kilogram meter cube per second cube into A in terms of basic unit. Question: find electric flux if E vector equals 2I cap plus 3J cap plus 4K cap Newton per coulomb and S vector equal to minus 2I cap plus 2J cap plus 3K cap meter square. Second, E vector equal to minus 3I cap plus 2J cap minus 4 cap volt per meter and S vector equal to I cap plus 2J cap minus K cap meter square. Solution: phi equals to E vector dot ES vector. So solving this, we get 14 Newton per coulomb meter square. Again, phi equal to E vector dot ES vector. Putting the value of E vector and S vector and taking dot product, we get 5 volt per meter answer. Now electric dipole. It is a system of 2-point charge equal in magnitude and opposite in nature, separated by a very small distance. Now dipole moment P vector. It is the product of magnitude of one charge with the separation between the charge. It is denoted by P vector. Thus P vector equals to Q into 2A into P cap, where P cap is a unit vector from negative charge to the positive charge. Magnitude of dipole moment P equal to mod of P vector Q into 2A. 2A is the distance between two charges. Unit coulomb meter. Practical unit dBA. D. 1 dBA equal to 3.3 into 10 to the power minus 30 coulomb meter. Dimensional formula. Dimension of P equal to dimension ATL. Find net electric dipole moment. P net will be equal to under root P square plus 2pp cos 60 degree, and solving we get root 3p or root 3qa. Electric field due to dipole. A. For points on the axis. Electric field at a point A due to negative charge is E minus vector equal to 1 by 4 pi epsilon naught Q by R minus A to the whole square into P cap. Electric field at point A due to positive charge is E plus vector equal to 1 by 4 pi epsilon Q by R plus A to the whole square into minus of P cap. Hence net electric field at A, E vector equal to E minus vector plus E plus vector equals to 1 by 4 pi epsilon naught Q by R minus A to the whole square P cap plus 1 by 4 pi epsilon naught Q by R plus A to the whole square of minus P cap. Taking Q by 4 pi epsilon naught common, we have equals to Q by 4 pi epsilon naught under bracket 1 by R minus A to the whole square minus 1 by R plus A to the whole square into P cap equal to Q by 4 pi epsilon naught, and under bracket r plus a to the whole square minus r minus a to the whole square by r square minus a square to the whole square into p cap, and solving finally we get E vector net electric field q by 4 pi epsilon naught into 4ra by r square minus a square to the whole square into p cap. For r very greater than a, r square minus a square to the whole square is equal to the r to the power 4. Hence E equal to q by 4 pi epsilon naught 4 r a by r to the power 4, 2 into 2 qa by 4 pi epsilon naught into rq equals to 2p by 4 pi epsilon naught rq into p cap, or equals to 1 by 4 pi epsilon naught p vector by rq.